I'm going through the question that says prove or disprove the equality x plus y plus circle plus z equals x plus y plus x plus z for the Boolean variables x, y, and z. Note that 0 o plus 0 equals 0, 1 o plus 0 equals 1, 0 o plus 1 equals 1, and 1 o plus 1 equals 0. Okay, so I want to talk about this question and maybe go through some of my thought processes, because it might be surprising. Like when I see a question like this, you might think you just have to know what like all these symbols mean and what Boolean variables are. Well, that's not necessarily the case, and maybe you do from the course, or maybe you don't, I don't know. But when I look at this question, I do wonder what this plus with a circle around it means, okay? And I do wonder what Boolean variables are, and so these things you have to figure out, I think, and you have something to work with even if you don't necessarily know them already. And I think this plus with a circle around it is definitely depends on the context. I mean, in some contexts it should go without saying, but in this context I think it needs some explanation. Okay. Boolean, I think, refers to logic, so it might mean that these x, y, and z could only take the value 0 or 1. Okay, so that would be a good guess for what they mean. And so, but we still don't know what this plus with the circle around it means. Oh, but look, in the note, I think that's what they're trying to address. They're actually basically defining what they mean for Boolean variables, and notice that they've only defined it for 0 and 1, and so in principle that should define what that symbol means for Boolean variables. So you can see 0 plus 0 is 0, so this is just arithmetic mod 2. 1 plus 0 equals 1, 0 plus 1 equals 1, and 1 plus 1 equals 0. And then now you even start to wonder what the ordinary plus sign means for Boolean variables, because, well, first you think, well, okay, if it's just plus sign without an explanation, let's just pretend it's ordinary arithmetic with whole numbers. But what happens when you do x plus y? So let's see, when you do x plus y, if x is 1 and y is 1, then you should get 2. And is 2, I mean, do you have to change 2 to 0 to make this defined first? I mean, 2 doesn't look like it's originally defined for this addition. So, I mean, I feel like there are some problems with this question, but you can probably still get the marks, if not get somewhere with this question, sort of while a little bit in the dark. Okay, so okay, if we play around with this for a little while, let's say like x equals 0. If x equals 0, and assuming ordinary plus, ordinary plus and 0, will just mean that the left hand side is y circle plus z, and in the right hand side this will be 0, 0, so it'll be y circle plus z. So the equality is true for x equals 0. Okay, so true for x equals 0. Um, but you know, is it true when x is not 0? And I think you get a problem straight away when you let's say y and z be 0. So okay, so you can suddenly let things be 0 because Boolean, if it's 0 and 1, it could be 0. And the note that they give you suggests that the two values are 0 and 1. Okay, so if you let y and z be 0, then left hand side should be just x. If we interpret the plus in a suitable way, and then the right hand side. So what's the right hand side? Well, it's x o plus x. And which is a problem. Okay, so I guess since we know it's true for x equals 0, then we're implicitly letting x equals 1. So then the left hand side is 1. But the right hand side, well, we said that this was equal to 0 by the Boolean algebra. Okay, so these are not equal. So so we basically disproved. I guess it's not really the equality; it's more like the identity. Okay, because it's you can't really prove or disprove if you don't know what the values of x and y and z are, because we can see it's true when x equals 0, for example. So I think when it says disprove, it means it's claiming this is true for all Boolean variables x, y, and z. So if you disprove it, you find a combination of x, y, and z such that the equality doesn't hold. And you know, up to not really knowing what some of these symbols mean, it's plausible that letting x equals 1, y equals z equals 0 gives you a situation where the equality doesn't hold, and hence disproving it.